The current model is that the metazoan last common ancestor possessed Hox cluster genes, which not only gave rise to the Hox genes in cnidarians, which for the most part are no longer organized in a cluster, and to the Hox cluster genes and para-Hox cluster genes in the bilaterian last common ancestor. A gene duplication occurred by the time of the bilaterian last common ancestor to produce the first of the central Hox cluster genes, and so thus there were 4 genes in the true Hox cluster and 3 genes in the para-Hox cluster by the time of the bilaterian last common ancestor. This must be inferred by studying the primitive descendants of this ancestor today, the xenocoelomorph flatworms. But there are problems. Since these lineages have evolved since the time of the last common ancestor, there have been changes to what the inferred sequence was in the ancestral condition. There have been gene duplications in some lineages, while there have been gene losses in others. And so therefore constructing ancestral genes using modern representatives is difficult, and sometimes one must study all of the members of a group, or at least multiple members, because one organism alone might not accurately represent the entire group. So there may not be model organisms which can stand in for an entire phyla. One must look at the sum total of all of the genes.